I start off the same way. I'm going to start by finding the restriction. So I do the x squared plus x minus 12 equals 0. And I'm going to solve by factoring. So that's x plus 4 and x minus 3. I set each factor equal to 0, so x plus 4 equals 0, x minus 3 equals 0. And I solve each. This one I subtract the 4, I find out that x cannot equal negative 4. And this one I add the 3, so I find out that x cannot equal the positive 3. So that's my domain. My domain is just the restrictions. X does not equal negative 4 or positive 3. And now I'm going to factor everything completely. I want to simplify this. So again, this is going to be x minus 3 over. This factors into x plus 4. I already did it once, x minus 3. And I cancel out any common factors, so I cancel out the x minus 3's. And again, when I cancel things out through division, it leaves me with a 1 in my numerator. So it's 1 over x plus 4. Okay? So now I need to decide, is each of these restrictions a vertical asymptote or a hole in the graph? If I look, the restriction that got canceled out, this guy right here, the x minus 3 got canceled, which means this restriction got canceled out, which means that is my hole in the graph. So I put a 3 down here. That's the x value for the hole in the graph. To find the y value for it, I plug it back into my equation. So right here, I could plug it into this equation. That would be 1 over 3 plus 4, which is 1 over 7. So 1/7. Ooh, that sounds like fun. Great point, Mr. Jansen. All right, and again, you could have plugged that in pretty easily in your head. Maybe I should include that down here where the actual, yeah, let's put it down here. 1/7. That's where that came from. I plugged the 3 in. So now I just have to decide about vertical asymptotes and then move on to the horizontal. The only restriction that's left, this guy right here, the x plus 4 is still in the function, which means that restriction's still there, so that's my vertical asymptote. Again, if it gets canceled out, it's my hole in the graph. If it doesn't, it's my vertical asymptote. And now horizontal or oblique, I compare the degrees. The degree up here, the highest exponent is 1. The degree down here is 2. Since the degree of the denominator is bigger, it means it's automatically horizontal again, so no oblique. And this time when the degree of the denominator is bigger, it's automatically y equals 0. So again, degree is the same. We divide the leading coefficients. Denominator is bigger, y equals 0. And now I'm going to graph this. I'm going to start with my asymptotes. The vertical asymptote is negative 4. 1, 2, 3, 4. Again, I use a dotted line. Y equals 0. It's right here. And now I just have to graph this thing. I'm going to choose a point. I'm going to do an XY chart, and I'm going to choose a point from each side of that value. So since the vertical asymptote is at negative 4, I'm going to choose negative 5 and maybe negative 3. I'm going to choose a point on each side. And I'm just going to plug them in. Okay? Let me give myself some space down here to plug it in. Yeah, good idea. So again, I'm going to plug this in. Let's see. That's going to be 1 over negative 5 plus 4. So that's 1 over negative 1, which is negative 1. That was easy. And I'm going to do the negative 3, so I plug the negative 3 in. So that's 1 over 1, which is 1. Well, that was easy enough. So I've got negative 5, negative 1, which is right here. I've got negative 3, 1, which is right here. And that gives me an idea what this is going to look like. I'm going to hug this line, go through the point, hug the line. Over here, I'm going to hug this line, go through the point, hug the line. I should extend that a little bit more. See, it's getting closer and closer to that line as it goes to infinity. And now the hole in the graph is the last thing I have to do. It's supposed to be at 3. Well, let's see, the x value 3, that's right here. So this is where my hole in the graph goes. And just a quick check, does that look like the ordered pair 3, 1/7? Yeah, it sure does. Now I know my graph is in the right place because my hole fell where it's supposed to be. Okay? And that's it. Moving right along. Ready for the next one. If I take a look at this next guy, again, I start off the same way. Every time, it's the same thing. Find the restriction first. I set the denominator equal to 0. And now I solve. I add the 1 to each side, so I find out that x cannot equal 1. All right? So that's my one restriction. That's what I'm going to use for my domain. And now I factor everything completely, so I've got g of x equals, build a bridge. This is going to be an x plus 3 and an x minus 2, and then I cancel out any common factors that I have, but I don't have any common factors. So since I don't have any common factors, nothing cancels out. All right, so now let's talk about my one restriction that I had. This one restriction that came from the x minus 1, well, the x minus 1 didn't get canceled out. It's still there. Since it didn't get canceled out, it means that one restriction is a vertical asymptote. And since there aren't any other restrictions, it means I'm not going to have any holes in the graph. There aren't going to be any. All right, I have my one restriction, and it ended up being a vertical asymptote. So too bad for the holes in the graph. All right, for the horizontal oblique, again, I compare the degrees. Here, the degree of the numerator is 2. The degree of the denominator is 1. Since the degree of the numerator is bigger, this is the one case where we have an oblique asymptote. So no horizontal, it's going to be oblique. Okay? If the degree of the numerator is bigger, it's oblique. And to find the oblique asymptote, I do synthetic division. In other words, this problem literally is saying x squared plus x minus 6 divided by x minus 1. Okay? Fraction bar and a division bar are the same thing. So I take the opposite of this guy and put it in my box. So I put a 1 in my box, and now I write down my coefficients, 1, 1, and a negative 6. And those guys came from right here, 1, 1, negative 6. So synthetic division, I bring down the first value, that's a 1. I multiply, 1 times 1 is 1. I add straight down, that gives me a 2. 1 times 2 is 2. I add straight down, that gives me a negative 4. And now I break out my secret decoder ring, and this is going to be 1 degree less, so this is an x plus 2 with a remainder of a negative 4. So I would put that over the x minus 1. But again, when I'm doing an oblique asymptote, I'm only concerned with the y equals mx plus b part. So guess what I get to do with that remainder? I just get rid of it. I hack it off. Because right here, this is my y equals mx plus b. That's the equation of my horizontal asymptote. It's in the form y equals mx plus b. It's got a y-intercept. It's got a slope. So it's going to be a diagonal line. Now I'm going to go over and graph these things. So x equals 1. That's my vertical asymptote that goes right here. The horizontal, or the oblique asymptote, y equals x plus 2. Again, it's got a y-intercept of 2. It's got a slope of 1, so that's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, down 1, back 1, down 1, back 1, down, back 1, down. And now I'm going to use a dotted line. That's terrible. I'm not happy with where I put that dash. Normally, I'm like a machine making dotted lines. So if I have a mechanical arm, perhaps I do. So now I've got my two asymptotes. Now I do the same thing that I did before. I use an XY chart to determine where this thing is going to be. So I'm going to do my XY chart. And again, I'm going to choose one value on each side. Make it easy on myself. Since the vertical asymptote is at 1, I'm going to choose 0, because that's 1 in the direction to the left. And then I'm going to choose 2, 1 in the other direction. And I'm going to plug each of these in. You can either plug it into the factored form or the original problem. I prefer the original problem for this one. So that's going to be 0 squared plus 0 minus 6 over 0 minus 1. So that's going to be a negative 6 over negative 1, which is a positive 6. So that's this guy. Now I'm going to plug the 2 in. So I've got 2 squared plus 2 minus 6 all over 2 minus 1. So let's see, that's going to be 4 plus 2 minus 6 over 1. 4 plus 2 is 8, minus 6 is 2. So I've got 2 over 1, which is 2. So now I have two ordered pairs. I'm going to go up here and plot these. 0, 6, it's going to be 1, 2, 3, 4, 5, 6, right here. All right. And the point 2, 2, 2, 2 is going to be right here. And now I kind of already know what this thing's going to look like. I know it's going to hug this line, go through the point, and hug the other line. And I know it's going to hug this line and go through the point and hug the other line. Okay? That's pretty gross looking. I didn't do a very good job, but that's okay. Well, maybe it's not okay. Let me try again. Well, this one wasn't bad. I didn't mean to erase that guy. I apologize. Let me try this one more time. Oh, that's much better. Well, I grazed the line a little, but that's okay. But you get the idea. We hug one line, go through the point, hug the other line. And that's it. Okay, there's no holes in the graph to worry about for this one, so that one's done. The last couple examples here is just understanding the relationship between the vertical asymptotes and the domains and stuff like that. For this one, I'm going to work backwards, okay? I've got the equations of these lines. The vertical asymptote is right here at the x value of 2. So the vertical asymptote is the equation of the line x equals 2. And that's easy enough to do. It's a vertical line at 2, so it's x equals 2. The horizontal asymptote, The same thing except with y. It's at the y value of 1, so it's y equals 1. And remember, the vertical asymptote literally came from my restrictions. So if I have a vertical asymptote at x equals 2, it means I have a restriction of x cannot equal 2. All right, because that's the one place that we're not going to have an x value. All right, the graph is never going to cross that line, okay, because it's a vertical asymptote. For the second one, I do the same thing. Here, the vertical asymptote is at x equals -1. The horizontal asymptote is at y equals 2. And those are easy enough to identify, vertical and horizontal lines. The domain, well, if I have a vertical asymptote at x equals -1, it means I have the restriction x cannot equal -1. Because remember, our domain and our vertical asymptotes are always shared in the regards that we have a restriction wherever we have a vertical asymptote. Okay? And that's it. I hope this was helpful, and good luck on your test tomorrow.